Hey, Chris, welcome to the podcast. Be good to do an introduction for yourself, where you're from and a bit of background, and I can kind of sit and talk about some of the things we're going to chat about today.
Yeah, absolutely. So currently, as you can see from my hoodie, I'm the cloud guy at PwC, and the official title is Director of Financial Services in consulting and helping customers to migrate to the public cloud. One of the things that I'm also is not quite officialized yet, but have credentials to gain the first AWS Database Ambassador badge for PwC UK. I'll be one of the first that we have in that space. It's a quite coveted area. You can see I'm a big AWS fan. I used to work over at CloudReach, and we were one of the people that brought AWS to market originally early on. And clearly what we're seeing now from then until now, clearly quite a lot of things have changed. You can tell from my accent, I'm actually British. So I was born in Oxford, grew up in San Diego, California. So definitely been around the block and around the world a bit. Possibility to experience a lot of different things. In my time, I haven't always worked in financial services. I've been in a lot of different industries, from public sector, private sector, telco, media, technology, product companies, consultancies, you name it. I've done a bit of everything from software build to advising customers. So a lot of interesting things I've seen over time, and had the good opportunity to experience a lot of the technology evolutions. I saw things like Java emerge. So I'm actually old enough to remember the birth of Java and its beta stages, the different versions of J2EE, a lot of the containerization stuff, the operating system wars, been kind of a wild ride over time. And now we're seeing the public cloud, its evolution, and the evolution of the kind of battleground that you see between the different cloud providers in that space as well. So I think I've been very fortunate over the time period in my career to see technology grow up and expand so much over those times.
Yeah, that's really good. So not get into the technology side, but I'm kind of curious, because as you just said, you're from England. Do you come back over here often then? Are you always coming back to the UK? And do you work between both places, or are you mostly...
No, so I'm actually based in the UK full time. So I work in London. I live next to Heathrow Airport, quite close to Heathrow Airport. And I have done for the past 8 or 9 years. Prior to that, I was doing consultancy services software build around Europe. So I actually haven't worked back in the States since my university days.
Oh, right. I'm going to say, because like San Diego to Heathrow is quite a different lifestyle, isn't it? So I didn't know if you...
Well, there is a direct flight.
But did you cut your teeth then from the technology perspective in the States? Is that where did you work over there, or was it more studying and then came over here?
So I did some work over there, but not much. Again, early stage career. So I'm an engineer at heart. The expertise is in distributed systems, distributed compute. And so I was focused on very early on, before threading was a thing. You had kind of the virtualization of threads on single CPU, and then the use of multiple systems and big compute grids. And that was kind of the area that I had picked as the most interesting to go and exploit. So more of the software focus side of things. But fortunately, I mean, if you think about cloud technologies today, cloud is just a big distributed system. And this is what you're seeing in a lot of the big systems that are out there. I think Kubernetes being, one of the prime ones.
Yeah, it's definitely come around like hugely over the years. I'm kind of curious to know them where it was then in your journey, because I'm guessing you're over here in the UK then and started your career here after studying out in the States, and then moved over here and then started your career, I guess, from the software side is by the sound of things and distributed systems. But then when did you really get into the cloud side? Like, when was your first exposure from outside of that into like cloud technologies? And I'm not sure whereabouts it was at the time. Did like an S3 only play at the beginning and EC2 play back when you started, or?
So I actually started using cloud really, really early on. I was doing some work in Italy, in the North Lake Garda, and noticed the advent, even before AWS came online. We started to see services from some of the kind of VMware virtualization. You started to get VMware as a service sort of thing, not really VMware cloud. And then some of the cloud services that backed off the back of that. So you have kind of KVM-based systems and early Linux distributions are capable of mild containerization, something called OpenVZ. And so we started using those very early on, because I was working for kind of small software development type ISP, initial SaaS type offerings that you started to see in the market. And a lot of the designs around those systems, for efficiency's sake, were built in a not quite containerized fashion as we know today, but definitely with very light virtualization, which is built into them. We're starting to use API-driven architectures, event-driven architectures, Though at the time, we didn't have a lot of the software systems that we know today. So you didn't have things like Kafka or Confluent. You didn't have the distributed databases that you see today, the Cockroach Labs of the world, right? Cockroach DB. You really had to kind of build things from the ground up, and there were kind of basic components you assemble together. And you also started to get some of the kind of early stage open source application servers at the time, Java world, and things like Glassfish and stuff like that. And so in the software that we used to build to deliver the SaaS solutions to clients, we would go out and deploy these technologies, and we would make use of the very first thing we used on AWS was SES at the time. And we're talking, 15, 16 years ago. So it's been quite a journey. And then when you started to get things like EC2, then that was just a game changer because you were able to build systems in a more dynamic way. And I remember us looking very early on at not only how we would deploy the infrastructure code, the DevOps as you know it today, but go back, 10, 12 years, we were looking at using the APIs themselves within the software to auto scale the software that was built. And this was all for efficiency's sake.
Yeah. So were you then working with application teams? I guess, were you like the bridge from an infrastructure perspective before, I suppose, kind of DevOpsy movements were happening around then anyway, wasn't it? So it's kind of a little.
Yeah. I've always kind of straddled the two worlds. So because I came from the software space and building applications, the infrastructure was being able to manipulate the infrastructure was actually something that I saw as coming into the development space. It was a way for us to avoid reaching out to the classic system administrator. And it made the development of the software a bit more efficient from an engineering standpoint. So we were, we had the APIs, we'd get access to the APIs, and then we'd basically manipulate those within the software as much as we could. Then you started to get the deployment pipelines and the rest of the maturity around the DevOps space, which in my view, I think it went in the early days a bit too far to the infrastructure side. And if you think about the balance between who was the system administrator at the time and the engineering function, I think the system administrator role evolved much faster than the developer role evolved into the infrastructure space, take advantage of that in the software. A lot of the projects that I had worked on early on, we took that more from the engineering side because there were smaller companies they're working for, and use of a system administrator in its own right was kind of an overhead that we didn't really see necessary. A lot of the developers took on that role. So there was DevOps from the other side of the fence. But of course, in the evolution of what we've seen in the industry, that's actually happened more on the SA side towards DevOps, DevSecOps, et cetera, where you set up the infrastructure in a somewhat static fashion, though using things like DevOps, CI/CD pipelines and whatnot for the management. So you have the rapid iteration behind that, but it's not connected to the software systems you're necessarily deploying. I think there's been a nice movement around SRE, when Google started to introduce that methodology, where we've started to see that come back a bit. System administrators caring about the applications being tuned for the infrastructure they run on, and a lot of the metrics that you're getting, the observability, then leveraged to make the software better. Bit more cooperation between infrastructure and software. Clearly, as we move into the realm of Kubernetes, I think infrastructure is largely disappearing, and that whole thing is starting to blend back up again.
Yeah, it's been, I kind of agree on the things you said, because I definitely agree on DevOps movement. It had a sense of irony behind it in some ways, because it was supposed to close down the delta between ops and dev, but the industry created a role behind it, therefore creating a silo between ops and dev by calling it DevOps. So it felt like a little bit of a rebranding, even though with the same problem. And then everybody was trying to abstract to like the roles themselves over time, even though the principles and methodologies were set out and aligned about what they were there to do and the challenges they were there to overcome. There was a sense of irony around, did create pillars, like a whole pillar of like DevOps who would do loads of doing outside of the dev, and the dev wouldn't necessarily know how they did it. And then they just got a dependency on the same people and then brokering like between them and the infrastructure. So really there was like an interface that became human between what the dev needed and then the actual infrastructure rather than an API, and then kind of like programmatically understanding how to use it. So it's kind of like quite funny to me. It's kind of ironic.
But I think there was a lot of good in that, right? Because the traditional sense, the infrastructure that you had before was static. So you had to go out, you had to buy tin, you had to order tin, you had to make a business case for tin, and the tin then had to last X amount of time, right? Even though customer requirements changed, you still had to kind of make your stuff fit in the tin. And so from a development standpoint, you were always very cautious in what you asked for. You'd go in and you'd say, yeah, I'm good with this, which is probably oversized 10 times for what I actually need it to be, right? And you have all sorts of problems of managing that infrastructure when it went wrong, or you couldn't get the right pieces, or you couldn't get fixed in time. The old world of the tin was completely different to what you then had in the infrastructure space. So I think one of the biggest developments that I found interesting, especially with the adoption of AWS, is when they introduced auto-scaling groups on EC2. So that was a real game changer because you could communicate back with the DevOps teams and you could have infrastructure which scaled. And you were able to take advantage or build software that was stateless, so you could take advantage of that scalability. You started to have to think about the design of systems, decouple the data parts of the system from the computational side of the system. Again, something that you would do classically in distributed systems, but wasn't really, because you were looking at 3-tier architectures at the time, right? So the applications that you were building, these are the kind of the Java enterprise applications. You were building EJBs, you were building the Java server pages, and this was all mishmash between the application server, the database, and a web front end forwarding and a proxy. So the types of applications you were building, they weren't exactly the same as the big microservices applications of today, where you're able to segment the problem in different places, able to orchestrate between different services really easily, and you're able to add horizontal scalability to components with an ease that you just couldn't before. You still had the constraints of the physical infrastructure. So I think even though we didn't really move fast enough from the development side to take advantage of the software-defined infrastructure, there were definitely a lot of benefits that wove their way into the applications as that came online.
Yeah, I think what's interesting is that the milestone movements in the market and in the industry came from, I mean, this is theoretical to a point, or kind of educated as well from reading, but I'm sure there's somewhere in between. But for an engineering business like Amazon to take a problem, they took the problem and found an engineering solution to the problem, which is like, how do I present infrastructure as APIs? How do I kind of present these things to be more like commodity to teams to be able to be enabled versus process and methodologies, which is another way to solve the problems. It's like, well, we've got this issue with development teams not being effective or fast enough or being detached from infrastructure. So we'll come up with like methodologies and principles over it versus solving from an engineering perspective. The same with Google, solving the scale from an engineering perspective, containers, how do we move faster than VMs? And so I guess different organizations saw the problem and took a different approach to the same problem than maybe some other people did, and they yielded different values. So kind of moved the industry forward along with the principles. It's kind of been quite interesting to see business constraints at scale with engineering talent, and then what they kind of came up with to solve the problems that then kind of moved the whole market along, really, because it kind of became like revolutionary, didn't it?
So, I mean, there are a few things in what you said, and some of which I agree with, some of which I don't. So the fact that Amazon did add APIs to infrastructure, but I don't think that's what changed the game from a cloud perspective. I think what Amazon did was shift the procurement cycle. So before, to scale, it was a finance problem. And what those APIs did was make that a technical problem, system administrator or other. The processes actually didn't go away, they just changed. So the early part of cloud consultancy was all about let's set up a landing zone, let's introduce cloud governance, right? These were major themes, especially early on in cloud adoption. And the people that got this wrong, it went dramatically wrong for them. Things got out of control. They didn't even know what they were spending anymore, right? And then we got FinOps started to come into place. We had to worry about how we were spending. And this just led to, it was the same governance in different ways. Ultimately, see the accountants, they made their way back into the area anyway. It just took them a bit longer to realize that the real revolution there was that the technology departments now had the ability to procure what they needed when they needed it to make the application run as best they saw fit and to evolve what they needed over time. And this has a whole series of challenges in the FinOps space in the how do I financially plan for that flexibility? And I think that's a problem that today no one's solved yet. In fact, I went around reInvent when I was there last year, and I realized that from the year before, the number of companies attempting to solve FinOps had actually multiplied as opposed to consolidating. And this told me that it's a problem, it's out there. People really haven't found a solution to that yet, because the moment in which you start to see maturity in that space, you'll start to see a lot of reconciliation. Businesses will start to fold one into the other, and you'll start to see a few main players emerge there.
Do you think that, to pick on that, the reason it's not solved is because of like you have to bear with me on this train of thought because I need to articulate in a way that makes sense. But do you think it's to do with like the accountability? Because who owns the budget is very different to who's controlling the infrastructure. And the way the infrastructure is being led is through applications and then maybe deterministic scale, right? So it just depends on how you manage to deliver and what the parameters are in the cloud. Hence also a problem because it's not one dimensional, right? So it's multifaceted on like how and what you've done in the cloud will then predicate the cost in the end. And do you think that's kind of the reason it isn't solved is because of all the different roles involved, a conduit into the cost? And therefore it's quite hard then to work out not just the prediction of the cost, but who's really owning the control of it in the end fully. Do you think that's why people are struggling to solve it? Or
I definitely agree with the complexity point. So the managing the cost of anything in the cloud really is quite complex. There are, on Amazon, I think there are something in the region of 18,000 SKUs and combinations of things that you can buy. So just priceless complexity is absurd. Now, most big businesses can't or won't just use one cloud provider. They'll use many cloud providers. So that complexity is multiplied many times over. In addition, engineers aren't really good at budgeting. They're not accountants. They're there to solve engineering problems. And there's a combination with a bit of the generational shift. So with cloud, we got used to, as consumers, having things immediately that don't break. Okay, I don't know if you ever experienced life pre-cloud and how the internet was back then, but that was the land of error 500. So every once in a while you had capacity problems, you had web server errors, because you had finite scale, right? Now in the cloud, you don't see that anymore. You've got the inverse problem. You have spikes in people's budgets. And of course, the problem is that trust is very difficult to build and it takes moments to destroy. And actually, if we think about the future generation, the millennials, Gen Zs, and Gen Alpha, they don't put up with kind of the classic BS my generation would have put up with. If something breaks, they lose confidence immediately. It's very difficult to build that back. It's very difficult to acquire them as a customer in the first place. They're used to getting things for free. They have generations of instant gratification, the digital natives, right? So as a business, even if you were a really harsh CFO, you'd do a lot of damage to your business if you started to say, beyond this point, we're not spending, because your entire business would collapse. Your customers would just disappear overnight. You can't do that anymore. And all businesses today are run or have a front door or have an interaction with technology. And this was, of course, exacerbated during the pandemic. We saw exactly how much technology could do and how far we were linked into it across all elons of basically everything. We even started connecting to the internet to order a pint of beer when they opened up the pubs, right? So this stuff had to work. It was, super important. I think the highlight of this is and going into Christmas, there's always a few wobbles on the payment system when you go and pay with your credit card. And the amount of anger, bad media, and attention that type of wobble sends through the ecosystem is incredible, right? It's an example of our dependence on technology. So they've got this interesting challenge of trying to balance the books whilst not being able to take away the service. And this necessarily means that the finance teams need to be more technically savvy, and it takes an evolution because the people sitting in those departments weren't technologists native. And so now you've got an even more difficult transition. Before it was, how do we bring developers and system administrators closer together? And those people at least were both talking tech. Now you've got an even bigger challenge, which is they're the techie guys. And how do you bring them closer to the people that were basically managing dimensions and SAP? It's a bigger jump. And that's why you haven't quite found any business that has really solved that completely. I mean, think about PwC. Even we have a product called Cloud Cost Assurance that attempts to solve this problem. But even as a traditional accounting firm with technology people in it, even we haven't solved that problem entirely. We're trying. We acknowledge it's a problem. We acknowledge we may be able to play in space, but it doesn't mean that we've solved the problem entirely.
It's difficult because if you're not, all of the conflicting elements around things in what you're saying, which kind of make a lot of sense, to be honest, but agility, being agile, not planning everything up front, right? Trying to build as you go, trying to iterate as you go, makes it unpredictable in some ways by design, right? You're supposed to design on the go to find the right outcome in the end, which in nature, which in itself means you don't know what it's actually really going to be at the end. So then to then predict something, not just from a consumption perspective, but even from an application perspective, in how it's even going to look at the end, when you're told that waterfall, obviously, if you were to do those things and therefore you'd never get out the gate and you'd be left behind because it takes you so long to build it and prove it not a good way to work. So it's kind of conflicted in some ways, like the models feed each other. You know, on one side, you've got, it's designed for like, yeah, just use what you want. And as much as you use, you'll just pay for. At the same time, you're like, well, I don't know how much we're going to use because we don't know what we're going to build. And there's other people over the top saying, how much is it going to cost? Because we need to budget for this. And no one knows, you know. And what is funny about all of that, though, is that I don't really hear, out of all of the cloud tools and conversations, is optimization tooling, as in like things that make it, that optimize the service you're building to be cheaper. It's all about how you manage the cost of cloud, if you see what I mean.
It's cultural, right? So then there actually is a tool out there, and I think it looks in the right way. So reInvent, not this year, but the year past, Amazon released a framework for environmentally friendly application design. So they started thinking about the carbon footprint of application. Now in the cloud, because compute is electricity, and electricity is sometimes powered by carbon when not by renewables, in reality, the amount of compute, the efficiency of what you build, is directly proportional to the amount of emissions that you're going to output, minus the location. Because some locations, of course, are greener than others. But the thing is that's something that the generation that's building the applications of today care about. Yeah, I think you'd be hard-pressed to walk into a development department and find engineers passionate about meeting the CFO's budget. I'm not really sure you'd find that. And then you have to consider also the outsourcing phenomenon, right? So I've never seen requirements go into an engineering house which say build to this cost spec, minus the fact that they say build to this time frame so that I only pay you this much. They're not thinking about the ongoing operational costs. Right? That's not inside the NFRs. It's not something which is dictated in the user stories. It's not something that's tested against. And so naturally, the engineers aren't really going to care about it. And then culturally, it's just something that engineers don't care about because they were used to building on infrastructure which was already there, basically. And the motivation behind optimizing wasn't to save money. It's because they couldn't get the tin fast enough. And so if the application or the thing or the needs evolve, they would optimize the application, make it fit in the same box. And this is, where you get things like application performance management, you get all the profilers and all that kind of stuff. So you can figure out what are the hotspots in the application? What is the bare minimum I need to do to fit this same thing in the box with a higher load? No one designs for that up front. Now, fast forward to this generation, think about, am I designing an application which it has an enormous carbon footprint? Let's take something big, which has a nice carbon footprint. Say you're writing a AI/ML, a data pipeline in Python, and you're running this on something like Databricks, right? Clearly, Python is not the most efficient language. It's all interpreted, and that's going to have an enormously higher footprint than, say, the same thing written in Rust on something like Apache Arrow. So you can make different design decisions which make the whole thing more efficient just by the nature of the compute that you're running. But they're more difficult. So why should you do it? Because they're going to compromise your timeline. So how do you communicate that from a business standpoint? There is a disconnect in the world of how we build software, which doesn't lead us to integrate the financial metrics. And then again, the problem that the finance people have today is on applications that are already built. And because a lot of the efficiency, when you think about performance efficiency, the greatest thing you can do to improve performance is actually to change the way the applications are built. That today is enormously expensive. And therefore, there's a cost of running it, yes, but the cost of changing it may be prohibitive. So not always can they intervene. It's a bit too late. It's kind of like the train has left the station to a certain extent. There's a bit of a chicken and egg problem around this, which is difficult equally. Let's go back to the infrastructure side, DevOps. The infrastructure is code bits, which are still separate for the majority of applications. And then you have the release cycle of the cloud providers. Every 6 months, latest and greatest thing comes out of all three of them. How many stacks take advantage of the new stuff? How does it fit? That's not even contemplated.
That's interesting. So what would you then, so I guess if you're saying that the financial teams are not involved, I guess where finance meets engineering, what you're kind of saying is like financial impact to your engineering, which probably does correlate to a point pretty much to the emissions too. So I guess they're like going hand in hand. The more you're consuming, the more emissions probable, and therefore the more you're spending anyway. So they're a little bit interlinked, obviously. But then are you saying then that teams should be designing for cost to condition upfront like decisions you're making technically, and that's probably the right process around it? Or are you saying maybe it's a technological problem and technology needs to solve the technology problem, or both? What's your view?
Well, I think there's definitely it needs to be taken into consideration. So you need to create a culture in engineering of thinking about not so much with the cost, but how efficient it is. Efficiency needs to become cool again. Efficiency is currently, maybe it's more cool today than it was 5 years ago, but it's definitely not as cool as it was when I was building software in C on 386s. At a certain point, one of the experiences I had in my life, I had the experience of looking at a performance engineering team, and their job was to take lines of assembly code out of a post-compiled application in C. And they were paid, given bonuses based on how many lines of assembly, how many instructions they could pull out. Now, that's something that made sense when you were running server applications on 386s, because otherwise the application just didn't work. And there was no other solution, right? You were too far down on Moore's Law, hadn't yet solved the problem for us, basically. So you had that challenge, and there was a culture of doing at a time, and it was incentivized to do that. And it was more because otherwise your application was perceived as unreliable. No engineer wants to build unreliable things. That's just not culturally acceptable in engineering. You want to solve the problem the best way you possibly can. Now, fast forward to today, especially in the cloud world, reliability, that's no problem at all. As long as your wallet can scale, so can the application. And the wallet's not sitting in the pocket of the engineers.
True, but then you can't, I guess, is this then around cost consciousness? I guess there's obviously because some of these things, like you're saying, like cultural, it becomes behavioral, and you've kind of touched on like generational elements on like how people are perceiving services that they're consuming as well, generationally, where everything becomes more accessible. So therefore you normalize, like your expectations become normalized to some degree because it's all you've known. So therefore you just expect then it to be the thing you've always known, if not better. But at the same time, then if developers are not being made to be conscious of costs at all, and are then also not rewarded for being cost conscious, then no tools, I guess, unless the tool was to coerce the behavior. Because I kind of imagine if teams knew how much things were costing, they'd probably be quite surprised. If they could see like upfront, this is going to cost X, or like this is cost you Y, and they were like able to see really from a service to service perspective really easily without any integration work to do, just part of their development lifecycle. I reckon they would probably do the right thing.
Well, it depends. So everybody's motivated by different things. I think it depends. So I think people do care, but when you're in a startup, so when your actions have an impact. So if you're in a startup and you design something which is bad, and I had an example of at a certain point, there was a customer that told me that they forgot to turn something off. It cost them 20 grand overnight. In a startup, that could be terminal in terms of an error. So clearly, because the teams work tighter together, they're all vested in the success of the business. Now, fast forward that to a much larger business. And actually, it's about the KPIs that have been set out to you by the system. And no engineer is going to have KPIs on the code that he wrote, how much that's costing in production. Because A, it's difficult to measure. And B, there would be an impact in terms of time to market. Because the other thing you have to balance out is that newer generations want things faster. So let's go back to the kind of granddaddies of this, the Spotify guys, right? Wizards in let's roll out the new feature and see if it works really, really quickly. Daily release cycles, perfect. But designing things for performance, that needs time. And if you're applying all the time, you're going to diminish that time to market. That may reduce your competitiveness. So there are trade-offs to be had. And I think what businesses are starting to learn is that there's a cost for some of these things that they're bringing to market. It's not just about method and technology, and you need to be able to try and manage those costs. This is why I'm a big fan of site reliability engineering, because that encourages optimization all the time. So you're looking at, this is something in production. You have an entire team of people which are laser focused on making sure it never goes down. It's more efficient. It's more cost effective, et cetera. Those guys have metrics for something which is running, for which they have the observability data, and then they have the ability to change the application to make it better. And that's their mandate. They're measured on that. Unfortunately, you rarely see site reliability engineering done well in any business.
That's true. I still think, though, if there was a tool, I'm still a believer that if the information's present and it presents itself in the right ways, then those KPIs, even in a large org, if there was a way to see cost of the service as you're iterating it because it was made simple to do, and everybody could kind of see that, and it was like, it wasn't obscured, right, or obfuscated from like, you just can't tell and no one knows. And then I'm sure there probably would be KPIs, because it'd be much more accessible to make them KPIs because you'd know what it was and where it's going across everywhere. I just think it's just because it's not so visible that it becomes an impossible type of KPI, maybe, because people will probably balk at the fact that, like you're saying, oh, well, us trying to work all this out is going to slow us down on delivery. You saying we need to now work this out means we're going to be slower. Something has to give at some point where, and maybe probably will over time, where if it's effortless to know and it doesn't take you engineering effort to know, then you might always try and design to be cost effective anyway because it's so visible to everyone, including you. I would have thought, I just don't think cloud costs attach to application delivery very well because it still attaches to more infrastructure and it doesn't have like any Conway's law elements to it. It's just like names and EC2s, right? It's just like bars on a spreadsheet or account IDs, or it's not, unless you put all the engineering effort in to do a really good job on tagging and everything else. And just generally speaking, it's so divorced from the application delivery in truth. It's almost.
But I think it's also difficult to know. So when you're talking about, when you get into the realm of building the applications themselves, there's innate complexity in the way that the algorithms are put together. And some of them, so there is such a phenomenon as the kind of sleeper type algorithm. These are algorithms that when run over reasonable size of data or a sample portion of data perform within their KPIs. But then the calculation of, there's something an order of algorithm called Big O. And one of the things that scared me was I went around and I asked, class and group of engineers straight out of university, do you guys know what order of algorithms is? Do you know how to calculate the Big O? And they said, the big what? And the problem with that is that the cardinality of algorithms, and this is both true for data and for their own efficiency, is what drives that cost metric. I once had an application that I had to debug, which had an unbreaked for loop. And what this caused under normal conditions, a few hundred records, no problem at all. All of a sudden, we had a client use case where they had over 1 million records in there, and it was taking 10, 20 minutes to run the same thing. And everybody's asking themselves, why is that the case? Why is that the case? It was missing statement in a line of code. Those things it's very difficult to see what that happens. I mean, the best prediction engine in the world is not going to look into the algorithms. It's going to look at what stack are you deployed on and try and make some predictions on if you're using that stack and it has that shape and on average, this is the number of transactions you can flow through, then yeah, we think it's going to do that. But actually, order of algorithms can be exponents, and they can be exponents of 2 and whatnot, and those can actually dramatically reduce your performance and increase your cost. It's a much more complex problem to solve in terms of how do I know what that application is going to cost me when I deploy it. It's not easily resolved.
Yeah, that's fair. I suppose there's too many permutations. I still think, though, there is an opportunity to, at a bare minimum, organize the information, the data in the right ways, because at least you can forecast if it's in a specific environment and it's cost you X and you're going to be moving that across multiple environments. There is a very easy calculation on the overall costs and the projections of what you're doing. I mean, forecastable without obviously the damage is done in one environment already, so you've incurred a cost on whatever it is you've engineered, but it's the magnitude at which you're going to scale that out, I suppose, at a bare minimum could be reduced.
And so you're looking at the observability, and this goes back to what you would expect on proper SRE team, as I was saying before, right? Is that if you have a team in place that is looking at in production, how is that really performing against the actual data that you have? What are the trends of that? And zeroing in on where you can make efficiencies, laser focused on making that better. Give them KPIs around cost, performance, and carbon. That is more likely to yield reliable results than trying to do things at deployment time.
And what do you think all that means into platform engineering, which is yet another overlay to some description, right? So you kind of have the platform engineering principles of reducing the accessibility of cloud into a set of commoditized things, right? And workflows and all these other stuff to make it even easier, to go even faster, which is then makes it even harder maybe then in the grand schemes to then work out
I suppose it depends on how you design things. We could go back to the operating system wars, right? There's a bit of a lesson to be learned on platforms and composition from that. So you had Windows, was largely monolithic type design platform. And then you had Unix, of course, was built on small components and composable. The Unix paradigm is kind of onion kernel paradigm that they use and a ring of applications that then are used to make the operating system hang together. Actually, what you find is focus provides robustness, scalability, and efficiency. Now, the problem is more the way that businesses tend to build these sorts of things. So I have multiple conversations with businesses that run programs or projects. And if you have a program, maybe even outsourced, say to somebody like us or any of the other SIs, and you say, build me a platform that does Kubernetes. We're going to build you a platform that does Kubernetes to your requirements for today. But guess what? Kubernetes, well, that continues to evolve. And the requirements that you gave me may not have been entirely accurate. Or you may decide that different sorts of things happen. When you start to deploy things on there, you realize, well, you forgot something. So how do you maintain the platform? There's a question, and I always think that it's better. There's a certain point, somebody, can't name because I don't know how many people said it, but somebody came out and said, every company is a software company. If that were true, then every piece of software released by a company would be a product and not a project. And therefore, when businesses operate with organizations like us, they wouldn't say, PwC, go out and build me Kubernetes. I could do that for you. Love to do it. Brilliant. But you actually need to be bought into it. So you need a team internal, which is going to work with us, build that platform, and then take over that platform, evolve that platform. You should really be using organizations like us for burst. So when you need something velocity above the baseline, then we come in and kind of help you with that. You need knowledge that you don't have, we come in and give you that knowledge that you don't have. But you need to take that away, bring that into your organization, make that part of what makes you unique. Build the product, and then you're successful even in the platform methodology. Build the platform as a program, and you won't. Eventually, you'll end up with a cascade of inefficiency. You'll have no means to untangle.
And what's your opinion on platforms that are not necessarily, because there's all this movement on platform as a product. And I think depending on your size and scale as a business, people probably deem lots of things platform's such an ambiguous term anyway, right? So people would be like, well, I've got CI and a few scripts and some Terraform, it's a platform. I don't know, is it a platform? I'm not sure. But it's you've done something, that's 100% sure. Whether that's classified as a platform or not, I don't know. And then I guess what's your opinion on how businesses should be thinking about platforms in general to support the business? Because scripts and glue and duct tape might be fine if it's the scale small enough, as in you can get by integrating a few things loosely or even tightly. But then the minute you try and roll out that scale it out across loads of different teams, it's not necessarily thought about from a workflow perspective or the end user in mass because you didn't need to. And then, I don't know, just talking around it, but would you say, what's your perception of platforms and then products as a platform and when you should and shouldn't be adopting those things?
In general, software design was most successful when it was based on components. Platforms are compositions of components that offer services to make developing software easier. You should ideally, when you're building software that solves a business problem, write as little code in the plumbing and as much code solving the business problem, boilerplate to business logic ratio, right? If that's high, your software has high value. If it's low, your software has low value, and you're likely to have a lot of repeatability within that, which, again, the economics of software, the more code you have to maintain, the more difficult and more expensive that's going to be over the lifetime. So platforms in general are a good idea because they embody this component-based design principle. They're giving you a lot of the plumbing for free. That's all standardized and it can be focused on, right? Now, equally, they're also difficult to build because they're solving horizontal problems, not vertical problems. And so they tend to be much more expensive to build and maintain because the engineering effort and hence the quality of engineering and the operating model, delivery model that you need to put in place around building something, maintaining something like that is going to be very different to building a verticalized solution. Just simply because of the complexity. The platform engineer doesn't know how the platform is going to be used.
True, that's very well articulated. I think I totally agree with that. But I think there is a perception of market manipulation to some degree on, I wouldn't say it was market manipulation, that's probably a bit harsh, but as it influence of the market on what it means and then perception of what it means. You see what I mean? people perceive what they're doing to maybe be actually like horizontally delivered, like you're saying, but actually with the way they've done it, it kind of wasn't, because they don't really know the difference of whether what they've done was vertically solved or horizontally solved, and whether they have really driven component thinking and like good architectural design principles. They might not really understand whether they are or aren't doing what is good platform design thinking in what they're delivering, and therefore assume they've built a platform. So I'm like, there you go. Yeah.
If we take the pure definition of a platform, the moment in which you have more than one use case running on a single underpinning piece of software or set of software components, you have a platform. Whether that platform is good, scalable, meets both the requirements in the most efficient way, that then goes down to the design and the thought that you've put into it. The take is if you've designed a piece of software which fit a component and it was vertically designed for time to market, and most vertical designs are, you're probably not going to get the best result when you reuse that on an entirely different use case, which sort of kind of fits. Kind of the square peg round hole type of situation. Yeah, hammer really hard, it'll fit. It's not necessarily going to give you the right result. This doesn't mean that there aren't things within the verticalized solution that can be adapted, thought of, extrapolated, turned into a platform, and then repurposed against both use cases. So there is a way in which you can evolve things from vertical to horizontal. They still require the same, if not more, engineering effort to do so. The fact of the definition of the platform, then you have the barrier between technologists and business owners, right? For the business, the definition of the acceleration and the time to market will dictate the definition of the platform. And by that definition, what I've described before, even if it is square peg round hole, is still faster time to market. So they are leveraging a platform in a business sense. It's not necessarily engineering nirvana.
Yeah, I guess it's one perception of the value, the attachment to value. Because usually platforms you can correct me if I'm wrong, but I don't think I've ever seen many businesses correlate revenue targets back into like engineering functions at a platform level. You might see things trickle down if you're part of a product team, and you might have a P&L, you might have a revenue target as a whole. What you then don't see is the attachment maybe from a business objective downstream of like, did you correlate yourselves to that revenue target, cross-functionally, or even in that vertical that you're operating within, to say, yeah, we did all this and it really accelerated the revenue number because that's what matters to the business. It's very rare you ever see that, I think. So it's very hard then to know whether what you're doing is actually bringing true business value. It becomes subjective or technically subjective on, what you've done. And I think that's where the problem lies on, was it value for money or not? Really true, I guess, for the business side. It's like, how do you know?
I think it depends on I've held the role of technical manager as well. And I've always found it quite easy to articulate the value of engineering in business terms. The key drivers are normally productivity, time to market, operating costs, for example. If you're using common components and designs, those things are easier to maintain and operate. They require less people. They have less errors. They're easier to fix. They tend to be fixed across a broader spectrum. And the drivers, the calculations around, I've reduced the opportunity cost of coming to market faster. That's undeniable. The size of the engineering team and the time necessary to deliver the output is, again, very easily measurable. So the benefits of, let's say, the platform, which is providing that acceleration, are quite easy to calculate. It's not rocket science, let's put it that way. Is it articulated in business normally? Not so much, but equally, there is very poor articulation on the requirement side. So think about the functional requirements and the gathering of those. You end up product owner, which has a backlog of functional requirements. It's very rare that the business owner asking for those requirements would peg a growth target to his KPI or his bonus, saying, you give me that, I'm going to make this amount of money. And so if you don't have that cascade, as an engineering manager, maybe able to articulate, yeah, you asked for that. If I built it from scratch, it would have taken me X. Instead, it's taken me Y, which is much smaller. So clearly there's a value there and I can articulate that. Further up the chain, it's really the business that need to evolve themselves in terms of, why are you asking for that? And what does it mean for the business in terms of value? Then that's value up to the chain. It's value to customer.
Definitely think, from my observation, one of the biggest problems I see is that disconnect from technology to business still, which is, even after all the evolution of tech and the evolution of cloud and the things we were talking about, and you guys have spoken about it as well just now and before, around like even the FinOps aspect and the financial aspects and all of those things are just recognitions of a detachment, I think, from how technology is really kind of meeting the business all the time. And it's kind of always slightly out of sync somehow, and they operate a bit.
Yeah, I think for me, one of the big trends was, what was it, 10 years ago, maybe 20 years ago, you had banks, for me, are technology companies in denial. They're the ones that say, we're not technology companies, we're banks. And I was like, but actually, you just deliver technology products. But they insist that they're banks. And so what they did many, many years ago is they outsourced all of their technology abroad to the lowest bidder, right? That led to enormous amounts of technical debt, which we're experiencing today, atrophy in the products, high operating costs, high cost to serve, the series of things which plagued them. And now you're starting to see a trend more towards insourcing again, because they said, well, maybe we are a bit more technological. Maybe we should do that. Unfortunately, the engineers have fallen a bit out of love with that, and they pay a bit of a sin tax to get them back in. So that mistake is actually quite costly. And it goes back to that point, right? If businesses acknowledge that they are software businesses, then you wouldn't have this disconnect. Because if you were a software business, would you hire a COO that didn't understand anything about technology? You probably wouldn't. It's the fact that you accept that, or you kind of in denial that you're not a software business, or you can thrive without software in some way, ignore the fact that it exists and still be a player in the market. That's becoming less and less true. Shift into the realm of now we've got generative AI. Now you're just seeing the boundaries of technology push further and further and deeper into business. So the message there is that business just really need to hire people in the business that understand technology. There's very little escaping that.
We're kind of coming to an end. So as well for the podcast, it's been fantastic, obviously, talk to you about all this stuff. If somebody wanted to get hold of you, how does somebody find you, by the way?
Well, I'm the easiest person in the world. Find me on LinkedIn through my profile. Look up my name, Chris Stura at PwC. Or I'm a consultant, basically, so I'm a gun for hire. And whenever anybody wants to have a conversation, they can clearly get in touch with and have as much of my time as they like.
Perfect. Anyway, it's been an absolute pleasure speaking to you, and thanks for all the insights as well. So that's been great.